Hi, today I am going to discuss about thyristors family. Till now, whatever I have discussed, that is basic thyristor. That is a unidirectional device, 4 layers, suitable for low frequency applications. But if these thyristors are used for different applications like bidirectional current flow applications or DC applications, then because of the limitation of these thyristors, these are not suitable for those applications. Or at higher frequency application, not too much higher, but up to 200 or 300 hertz applications, if it is required, then a special type of thyristors are used. So research continues to develop different types of thyristors. Based on that one, today we will discuss about different thyristors. So depending on the physical construction and turn on and turn off behavior, thyristors are classified in different categories. First one, phase control thyristors. This we have discussed in detail. The characteristics of this thyristor: turn off time is 50 to 100 microsecond. So it is not used for very high frequency applications. Suitable for line frequency 50 Hz or 60 Hz. Low switching speed applications, HVDC systems, and these thyristors are also known as converter thyristors. So it is the simplest thyristors which we have discussed till now and is known as phase controlled thyristors. Now, if the thyristor is used for AC applications, then there is a requirement of bidirectional current flow. For that, scientists developed this bidirectional phase controlled thyristors. It is nothing but two anti-parallel thyristors. The rating of this thyristor up to 6.5 kilovolt at 1.8 kiloampere it is available, used in volt ampere reactive compensator. That means reactive power, if it is required to compensate in different types of loads. Sometimes reactive power is to be fed across the system, sometimes it is to be drawn from the systems. So in those applications, this bidirectional phase control thyristor is suitable, as well as it is very much popular in motor drives. In AC motor applications, induction motor, synchronous motor control, these bidirectional phase control thyristors are used. Third one is fast switching thyristors. As we know, there are 4 layers and 3 junctions. Because of that one, at the time of turning on the thyristor, it takes time to break all the 3 junctions, and at the time of turning off of the thyristor, it requires enough time to build all the 3 junctions. So the thyristors cannot be used for high frequency applications. Based on that one, a special type of thyristor is developed, that is known as fast switching thyristors. In this type of thyristor, different doping level of P and N type of material is used, and thickness of the layer is changed accordingly. And these fast switching thyristors are suitable for little bit more, you can say, higher frequency applications. Turn off time is very less, it is 5 to 50 microsecond. This is used in case forced commutation is required. That means, here let's discuss little bit about the commutation. Commutation means nothing but turning off of thyristor. There are basically two types of commutation: forced commutation and natural commutation. Natural commutation, in case of AC supply, automatically reverse voltage appears across the thyristor and the thyristor gets turned off. So that's why the method is known as natural commutation. But if reverse voltage is not applied, but by force we have to turn off the thyristor, then that is known as forced commutation. By applying some passive components, inductor and capacitor, some amount of energy remains stored across the inductor and capacitor, and the combination of that used to turn off the thyristors. More about this we will discuss in DC choppers. Wherever forced commutation is required, fast switching thyristor is used. It is also known as AC inverter thyristors. Next one, light activated silicon controlled rectifiers. It is nothing but photothyristors. Whenever isolation between driver and power circuit is required, then this kind of thyristor is used. Available rating of the thyristor is 4 kilovolt and 1.5 kiloampere current. It is generally used in HVDC system, bar compensators. Next is bidirectional triode thyristors. These are also known as TRIACs. This you can find in latest fan regulators. In this thyristor, just like basic thyristor, three terminals are there. But the speciality of this thyristor is that in both directions current can flow. It is similar to two thyristors connected in anti-parallel, and a common gate is there. Current can flow from MT1 to MT2 as well as from MT2 to MT1. So across this common gate terminal, positive supply and the negative supply is given to turn on the TRIAC. For bidirectional current flow, this positive and negative supply of the gate is given to turn on this TRIAC. This is also known as thyristor, which can be used for AC, or triode, which can be used for AC. That's why the naming is TRIAC. Next is reverse conducting thyristors. It is a special type of thyristors which allows current to flow in reverse direction also. As we know that thyristor is a unidirectional device. But what will happen if reverse direction current is also required? So to allow that reverse direction current, anti-parallel diode is connected. In positive half cycle, current will flow from thyristor, and in the negative half cycle, current will flow from diode. That's why the naming is reverse conducting thyristors. Forward blocking voltage of this kind of thyristors is 400 volt to 2 kilovolt, and current rating up to 500 ampere is available. Reverse blocking voltage is 30 to 40 volt. So based on different applications, these are different types of thyristors, and accordingly it is selected for particular applications. Seventh one, it is very interesting and popular thyristor, gate turn off thyristor. Till now we have discussed that a thyristor can be turned on by applying a positive supply across the gate, but we have not discussed till now that how the thyristor can be turned off. We have discussed about turning off of thyristor, that reduce the anode current less than the holding current and allow enough time to settle down the excess carriers. At the same time, we have to apply reverse voltage across the thyristor to turn off. But in this gate turn off thyristor, across the gate itself, if negative supply is given, then the thyristor will be off. So when positive supply is given, it will work like a normal thyristor, and when negative supply is given, thyristor will be off. So it is one of the advantage of this gate turn off thyristor. At the same time, this thyristor has some disadvantage. One of the important demerit is that a large amount of gate current is required to turn off the thyristor. It is popularly used in different applications, generally in forced commutation applications. Wherever natural commutation is not available, then these GTOs are used. Research continues to develop different types of thyristors to remove the demerits of earlier one. Advanced thyristors are developed. Based on that one, a new type of thyristor is FET controlled thyristors, field effect transistor based thyristors. Here a MOSFET is connected in parallel with the thyristor. Now to turn on the thyristor, we know that a minimum gate to cathode voltage is required. To obtain this minimum gate to cathode voltage, a MOSFET is used across the circuit. So first MOSFET is to be turned on, then voltage will develop across the resistance, and that voltage will supply positive current to the thyristor, and the thyristor will be on. Now one of the advantage of MOSFET, we know that its internal impedance is very high. So this circuit can be used for isolation between the driver and power circuit. Then next one is MOS turn off thyristors. Here it is combination of MOSFET and GTOs. Now to turn on the thyristor, a gate pulse is given, and to turn off the thyristor, a gate pulse is given to the MOSFET. One of the advantage of this circuit is that in case of GTOs, we have seen that a long or large amount of negative gate current is required to turn off the thyristor. But here a small amount of gate to source voltage is required across the MOSFET to turn off the thyristor. So this is the basic difference between GTO and MOS turn off thyristors. So till now we have discussed different types of thyristors based on the applications, based on the characteristics, turn on time, turn off time, physical structure, input impedance. These thyristors are suitable for different applications. So today we have discussed about different types of thyristors. Basic thyristors already we have discussed. Based on that one, many more types of thyristors have been developed, and those thyristors are suitable for different applications. Just the basics of those thyristors we have seen. Applications of these thyristors we will see in phase control rectifiers, inverters, cycloconverters, DC to DC converters in the coming classes. Thank you.